Hi everyone. Well, welcome to today's webinar, AI Ready Code, How to Scale AI Safely Without Sacrificing Quality. We're very happy to have you here. We'll wait a minute or two for everyone to join, but I'll give the mic now to our moderator for today, Luca Rossi. Welcome.
Thank you. Thank you, Romanella. Welcome, everyone. I'm excited to host this webinar about, I have to say, one of the most relevant topics today in software engineering, that is how to scale AI coding without sabotaging yourself and your code quality, I must say. So we'll have Adam and Marcus from CodeScene to talk about the state of AI coding today and how to enforce code health in your AI coding. And then Stuart from loveholidays presenting an awesome real-world case study. So to get started, I'll leave the stage to Adam to kick off this presentation.
Thank you very much, Luca. And good afternoon and good morning, everyone. So I want to start by exploring where we are today with AI coding. And what better place than to start from what is being sold to us? What are the expectations on AI today? And you have probably all seen headlines like this, that there will be no human programmers in 5 years, a prediction made 3 years ago, or how AI outperforms human programmers. Or why not my personal favorite, Mark Zuckerberg, who made a claim that AI will replace mid-level engineers by 2025. That didn't really happen. But to Zuck's credit, he's only a couple of months late, so who knows, maybe now in March. So anyway, the reason I'm showing you this is because there is a massive expectation on AI. So what happens when these amazing tools and technologies meet reality? Well, what we have seen is that the effect from AI tends to be in two different dimensions. The first one is correctness, quality. So what we have seen in studies, and these are all third-party studies, and you will probably get access to a slide deck afterwards. You can look up the references. The first thing that tends to happen is that defects go up, and they go up dramatically. So more than 41% more defects after an AI adoption in this first study, done on 600 programmers. But what about speed? Well, this one is really interesting, and this is one of my favorite studies on AI coding. So this is an experiment that was done on more than 1,000 open source projects. They all get access to modern coding tools like Cursor, and they adopted AI. And what they found was that there was a steep increase in velocity. So in fact, during the first few weeks, velocity was up 200%. So it seems like a massive win. But fast forward a couple of additional weeks, and after 2 months, all these initial velocity gains and then some were fully canceled out. And the reason for that, a massive increase in AI-generated code complexity. So the question is, of course, why these expectations and why this slightly more depressing reality? We think there is a good reason for this, and that is that context really matters. And context in this case is largely about code. So code is context. And our working hypothesis for this webinar and a lot of the stuff me and Marcus are going to cover is about how machines tend to get confused by the same patterns as humans. And the foundation for all of this to reason about good versus bad code will be code health. And code health is not just a concept, it's a metric. And those of you who are already using CodeScene, you're probably well familiar with the code health metric. For those of you who haven't seen it before, I want to give you a very quick 1-minute introduction to code health. So the way code health works is that it operates at the file level. So we take every single file with source code, and then we analyze them. And we analyze those files for code smells. That is, coding constructs that make the code hard for humans to understand. And these code smells, they typically come at 3 different levels. So first of all, we look at module and class level design issues. Examples include things like low cohesion, where you have stuffed too many business responsibilities into the same class. Now that class becomes hard to understand because you need to understand all these business rules to make sense of the code. And there's, of course, also a massive increase for things like unexpected feature interactions, some pretty nasty bugs. And then we also analyze the code at a function level, like how well constructed are the individual functions. And here you might find classic code smells like copy-pasted code, right? Duplicated knowledge. That makes the code hard to understand and hard to modify. And finally, at the implementation level, we look for accidental complexity in how the code is implemented. In particular, we pay a lot of attention to the conditional logic. And you might look for code smells like deep nested complexity. So you have if statements inside if statements, inside if statements, and so on, which is a pattern that puts a horrible cognitive load on any developer. So these are just some examples of code smells that are included in the code health concept. In total, there are 25 metrics that we look for. And then we have algorithms that can weight together the frequency of those findings and their severity, that is how deep do the problems go, and use that to score and categorize every single piece of code as being one of these 3 different categories. So the one you would like to have for most of your code is the green category. That means the code is healthy. And that means that it's easy to understand and easy to modify with low risk. They have increasing levels of unhealthy code. So what's interesting with code health, and we're soon going to connect this to AI, is that code health is a code quality metric that correlates with business metrics in terms of faster and better. What do I mean by that? Well, if you take a look at the graph here to the left, that's a graph from the Code Red paper that we published a couple of years ago. You see the 3 code health categories on the x-axis. On the y-axis, you have the time and development. Like how long does it take to implement a task, change the code, depending on the code health category. And what you see here is that if you have unhealthy red code, it can take up to 10 times longer compared to a corresponding change to green code. So it's very clear that code health gives humans a speed advantage. And what's extra interesting now in the age of AI is that AI is going to accelerate the creation of new code. And we're going to see much, much more about that, in particular in the case study from loveholidays. That what that means is that we want to ensure that whatever code AI generates, that it's healthy code. Otherwise, we're just adding to the technical debt problem in the industry. And finally, what we also see in another line of research is that healthy code has the advantage of being much, much faster to review. And this is one of the things I've experienced myself with AI. I tend to read much, much more code than I write. So anything I can do to simplify that code review, that manual code review, is very likely to speed up the whole delivery flow. So code health has been a super important metric for humans. But what about AI? So I'm going to hand this over to Marcus to talk us through how code health plays together with AI.
Thanks, Adam. Thank you very much. Hi, all. So I'll present highlights from our most recent study, which we'll present at an academic conference in Brazil in April. And in the paper, provocatively titled Code for Machines, Not Just Humans, we systematically study how capable LLMs are at working with code of different quality. So here we use refactoring as a proxy of software development. And the code we study, it comes from DeepMind's AlphaCode training set. So you might remember when this AI solution, AlphaCode, made the headlines. It was published in Science 4 years ago. If you don't remember, it doesn't matter so much. But you should know that AlphaCode was trained on solutions from competitive programming. And believe me, there are many, many code smells in competitive programming code. Of course, since it's all about submitting a working solution as fast as possible. And this is good for us. And even better is that the tasks in competitive programming, they come with test cases, because this is how the judges determine who wins. And this makes also the tests very reliable, which is also very good for us, because that is far from a general truth in software engineering, right? So we sampled 25,000 files from the AlphaCode training set. And what I'll show now is first results from general zero-shot prompts along the lines of what you see here on screen improve the maintainability of this file. We studied this for a series of open weight models from big providers. You see them in the corner here, and we also included Sonnet 4.5 from Anthropic to represent state-of-the-art. And to evaluate this, we look at test pass rates and also code health changes. So time for some results. So what you see here is the test pass rates as a function of code health. So on the x-axis, we have the code health. On the y-axis, we have the pass rates. You see here results for 5 LLMs, and then also the agent Claude Code here in brown on top. And the main finding here is that we see this consistent trend across all the LLMs, that the pass rates are higher for high-quality code. So it really shows that healthy code is needed for successful AI deployment. It appears that the LLMs are confused in the same ways by the same constructs as humans. So this paper was limited to Python, but we have since then also generalized this and found the same results for C++ and Java. A very important point here I want to stress, though, is that passing test cases, it's only one dimension of successful refactoring. So let's look closer at the top approach here. That was Claude Code in brown, and what actually happens when we add effectiveness to the mix. So we also want the refactoring to be effective in removing code smells. That's why we do refactoring, right? So here are the same curves, but now there is an added dimension. You see here the different shades of blue as for the data markers here. And the darker the blue, the higher fraction of refactorings of this model actually improved the code. So what you see here in this figure is that to the left, you have darker blue, and to the right, you have this trend of lighter blue. And on top, we see that Claude Code is not very eager to remove any code smells at all. Instead, it's highly conservative, focusing way more on renaming variables and adding annotations, and this gives you a high pass rate, but it's a very light blue, so there is very little refactoring effect. So the takeaway message here is that passing tests, well, that's not so hard to achieve, but reliably improving the code, that's harder. And we'll talk more about that in the next section, but this is a good point in time to actually pause and open up for questions, I think, Luca.
Absolutely. So thank you, Adam and Marcus, for the super interesting points so far. If anyone from the audience has any questions that they want to ask, feel free to do so. In the meantime, I guess I will break the ice and just point out a few observations of my own while the rest of the audience can ask questions in the chat. So I think these findings are extremely interesting, especially because we are used to looking at just benchmarks about AI being able to solve tasks from this or that benchmark, but we are not looking at code health and what happens at scale usually. Something that pops in my mind is that there is this narrative that AI is kind of democratizing coding for everyone, but it feels like by looking at these numbers that basically the teams that are writing good software are also the ones that are getting the most benefit out of this. Because if you get teams that write good software, they're already fast teams, and if we are saying that AI makes them even faster, my impression is that are we like widening the gap between the teams that were already like the best teams and the rest of us, the average teams? Is that what you're saying? Feel free, either Marcus or Adam, to take on this.
Yeah, I can go first if you want. I mean, what we have seen in previous studies, and not only in our research, is that AI tends to amplify effects, right? If things are really well maintained and good discipline in the team, it can really make you speed up things. If things are not so good, it can also amplify you in the wrong direction. So I think we will see a big gap in industry actually when it comes to AI adoption, how successfully you can run this. The democratization effect is also there, I think, because it lowers the thresholds. We will have many new code producers out there on this planet, and they are not trained in engineering in any way, and they don't need to be to create simple code.
Yeah. I can just add to that I completely agree with Marcus. That's my experience and learnings too, that AI is going to amplify both good and bad in organizations and in code bases. What I think interesting and my main takeaway from these studies is that I was surprised by how strong this signal is. Yeah. And historically, the threshold, the cutoff point for healthy code has been 9.0 on a 10-point scale. But what we see in these studies is that it might not be enough for AI to be successful and sustainably work, not only today, but also next month and next year. We most likely have to push all the way up to approximate a perfect 10. So AI kind of raises the bar on code quality, in my experience.
Yeah. So I'm picking also a question from the audience from Jamie, who asks that as well as a higher code health, how does unit test coverage influence the effectiveness? Who wants to go?
Should I take that one, Marcus?
Yeah, you can start. You can start and I can fill in. Yes.
I start and then you correct me. Well, how about that?
Let's see.
So so the thing is that me and my team, we have been doing close to 100% agentic coding over the past 4 months. So we have really lived through this. And one thing I see is that just as code quality is more important than ever with AI, so is good testing, good unit testing, good integration test. It's really, really essential. And unless you have these tests, then the agent simply won't be able to accomplish the task, right? So I tend to focus most of my time on getting the AI to write really, really good tests. I spend a lot of time reviewing those tests. And I also put the bar for code coverage, a metric I largely ignored in the past. I started to put that one ridiculously high, and I want to aim for close to 100% coverage from unit tests. So to me, that has been an essential part of succeeding with agentic AI.
Yeah, so I would like to second that then. So I have a background as a software testing researcher, and with AI, I tend to say that unit testing has never been as important as it is now, right? Because things will just move and cycle so fast that you really need to have the good feedback loops in place. And well, that's what you need your unit tests for. So yeah, super important to maintain good coverage of things that move fast.
Yeah, absolutely. And I want to touch back on something that Adam said, that is, let's make the threshold for test coverage even ridiculously high, right? Because writing tests is kind of cheaper now, right? Now that AI can help us with that. Do you see a trend in which, yes, we are aiming for high code health, but now that we have AI that can help us with that, we can aim for even higher code health that we would require from pure human code, because in a way, writing software is cheaper. So even code health can be cheaper if we enforce good code health, good encapsulation, good testing, thanks to AI help. What do you think?
Yeah, I definitely agree. That's been my experience too. I mean, once you get over a certain minimum bar, then it becomes very close to free to kind of push ahead with the rest, for both code health and code coverage. So I'm going to show you some examples later on how we use agents to automatically uplift and refactor code. And it's the same thing with coverage. The trick with coverage is, of course, that we want to make sure that it's a sustainable coverage, that the tests are good enough and that the design is good enough that agents can continue to iterate on them.
Yeah. Yeah. So I'm also mindful about time. So I think we can move to the second part of the presentation and then pick up more questions from the audience after that. What do you think?
Sounds perfect.
Sounds good. So let's get back and try to connect all these dots that we've been building up to. Is there a way to get AI speed with quality? So I think there are several really, really important use cases coming out of the research that Marcus presented. One of the most important ones is that if we know upfront through the code half measure which code that is AI friendly, where we are likely to succeed with AI, versus the code that is not yet AI friendly, then we can use that to pull risk forward, right? And I want to show you a simple example on this. So this is a code half visualization from CodeScene. And you see here, each file with source code visualized as a bubble, and the color of that bubble reflecting the code half of the underlying code. So by just looking at this visualization, I can very quickly see where the AI safe areas are, where I could most likely apply agents today to accelerate feature development, versus the areas that would be way too dangerous to give that level of autonomy to. So rather, what I would do in that case is I would target these two areas for an uplift to improve the code half so that I can reap the benefits of AI there as well. Another really important thing is that we can use AI to do that uplift. So this is really, really interesting that we can use AI to fix the code so that it becomes AI ready for real. And I want to show you an example on that. So to the right, you see a screenshot. So this is from my development environment. It's a Copilot chat in VS Code where I'm running Claude Sonnet. And what I've done is that I've installed the CodeScene MCP server. And the CodeScene MCP server is interesting in the sense that it does two things. First of all, it gives the AI a goal, like, hey, don't allow the code to deteriorate, uplift it to a perfect 10. And second, it also gives the context needed for the AI to succeed on that goal. And that context includes a complete code half review. So you see some simple examples here. So first of all, we see that the AI started an uplift and it managed to improve the code from 8.9 to 9.53, whatever that means. And we then see that the AI continuously calls back to the MCP to reevaluate the code half. And if we follow this very, very simple process, then our outcome is going to be AI-friendly code that we as humans would love too. And that's really, really important because our task as humans, I find, I spend much, much more time reading code now and making sure that it works at an architecture level, at the design level. So I want that code review to be cheap and effortless. So we still have a human audience, even if we aim for AI-friendly code. And the question is, of course, how well does this work in practice? Marcus has hinted at LLMs being conservative, that they are very, very careful with making deep structural improvements. And this is something that we have recently seen in third-party research. So there's a really good paper that came out just a couple of weeks ago that studied agentic refactoring at scale. And what they found was that, yes, AI agents are super happy to do refactoring, but they will not consistently improve overall code quality for exactly the reasons Marcus mentioned. The agents are going to be very conservative, do small stuff like maybe renaming a variable, and not the deep structural improvements that a skilled human expert would do. So, Marcus, how do we tie up the dots here?
Thanks, Adam. So you remember the curve showing how conservative Claude code is? It was brown in the previous plot, now it's blue here, it's the same curve. We have now investigated the effect of giving Claude access to code health in its workflow through the MCP server. And you see that here as the orange curve. And the first thing you notice is that the curves largely overlap, but there is a big difference here, and that's how dark the blue data markers are here. Looking closer at these differences, we see that the fraction of files that Claude improved without the MCP server on its own, it's here in pink. It decreases rapidly when the code quality is high. It doesn't do very much if the code quality is high. It's very conservative. But if we give code health guidance through the MCP server, we can give Claude this optimization target and let it iterate in that direction and actually make the structural improvements we want to have when it's refactoring, right? Without breaking much. So this is really cool. So this means that we really can use the code health score as the compass for the coding agents, guiding them toward maintainable code. And we've collected way more details on this. This is very new research on this webpage. You can have a look at that after the webinar if you're interested in that. Again, we have worked on generalizing this. So here are results from running the same design of an experiment with a self-hosted open source agent called GPT-me. And it's propelled here by a medium-sized open weight model. So now it's a less capable model. We use Qwen3 here for this. And we put the code health instructions in the agent's MD file, and we refactored the 25,000 files in our dataset, the same dataset from the AlphaCode training data. And here you see the result for C++, Java, and Python. And what we see here is that the MCP server and the code health, it keeps the refactoring effective, as you see here with the dark blue data markers. And we also see the previous trend of higher test pass rates for higher code health. And that's very interesting to see that our findings generalize so nicely. And then there is one final thing I want to highlight here in this chapter, and that's about token counts. So as you might have experienced, is that agentic AI, it's very token hungry, right? So we have very recently added the perspective of token counts. We instrumented that last week and we got the results over the weekend here. So now I will show you also a fourth dimension in this plot. I hope you're ready for it. Same curves here again, but now you see the diameter of the data markers here, showing the relative median token counts when refactoring the files of the corresponding code health score. And what you see here is that the bubbles are bigger on the left-hand side here, and they shrink, and they are the smallest for the healthy code when it actually crosses the code health 9 bar. And there is indeed a significant decrease in token counts here, statistically significant difference. And the output token counts for healthy code for the 3 languages here, it's around 20 to 30%. This, of course, translates to money. So there is a nice takeaway from this study here that deploying agents in healthy code, it's both safer in terms of passing test cases, and it's also cheaper. And again, I think we're ready for questions, Luca.
Yeah, thank you, Marcus and Adam. This was super relevant. So first of all, I think instead of picking up a single specific questions, there are a few questions that look like similar to me in the sense that there is like an underlying theme. It looks like about, okay, but what if I have a code base that is not that has not a great code health, like it's not AI ready, it doesn't have a lot of testing, right? So the question might be, how do I get better? Should I like retrofit unit tests, like Daniel is saying, to what we have today? How do I work in baby steps, right? Or is it refactor everything first, even realistic with today's tools? Well, how would you go about it?
Adam, I think it's for you.
Yeah, so I would go about it by turning back the clock a couple of years to your CodeScene. I mean, which was the start point for CodeScene. And in particular, I would like to bring up the hotspot analysis, which I think is super relevant in the AI space. Because the good news are that even if most of your code base isn't healthy, a lot of that technical debt and a lot of those code quality problems don't really matter. Not for humans and not for AI. Because development activity is extremely unevenly distributed. And that's simply because some parts of the code are much more relevant for your roadmap. And what you can do with the hotspot analysis is that you can identify those unhealthy hotspots. So those are the ones I would target for an uplift. And you might remember when I showed you this code health visualization before, it's quite frequent that I find this, that inside a code base, parts of the code can be AI friendly, where a lot of the code isn't, right? So you can have both states of AI readiness inside the same code base. So my recommendation, focus on the hotspots, get them under tests that are good enough, and then do the uplift with AI agents until you can start to accelerate. That takes you really far in my experience.
Yeah, I completely agree. It turns out, I think, as we've known from your analysis, that even if your code base is large, you can get a big uplift even by upgrading very few pieces of the code that are the ones where the most activity happens. So I want to pick this question by CAB, who asked, refactoring code will result in rewriting a lot of unit tests. How AI can help with making sure the unit tests stay relevant?
I have something to say, but maybe you want to start, Marcus.
I think this is a very interesting question. I can start by saying that, and I think we will learn a lot more about that when we start deploying AI at scale in various companies. We need more case studies. You'll hear from Stuart very soon, actually, about how they have taken care of it. But I mean, the regression testing will be super important when you target your AI uplifts, right? And as you said, how can we make sure? I don't have a good answer, actually. I'm evidence-based, so I need to run a good study on it first. I have some ideas, but Adam, I think you can go first.
I mean, so what we do in practice in our team is that we, like I said earlier, we had code coverage as one measurement. And code coverage, we use gates. So you're not even allowed to commit any code unless you reach this target of, I think we have 98 or 99% now. So that ensures that there are at least tests. What code coverage doesn't do is to ensure that those tests are good. So this is where the human expert comes in. So quite often we spend a lot of time reviewing our tests. And what I really, really like about AI, and this might be my favorite part of agentic AI, is that it allows us to try out different options. So I can very easily ask the AI agent to refactor a test that I just need to point it in the right direction. And once I've simplified the test, then it becomes quite easy to, as a domain expert, to reason about it. Is this the right set of tests? So I think, and I'm not yet at a point where I think that process can be automated, but I'm learning as well.
Yeah, everyone is learning around, right? And I think you can also use AI to test your test cases, right? We've had mutation testing since the 70s in the academic space, but it has never really taken off in industry. Who knows? AI might open new doors actually for more advanced testing techniques also, because you need to do quality assurance of your test cases as well. And this is going to be super fast when you start iterating faster with AI. Interesting times.
Yeah, interesting times ahead indeed. So I'm picking another question by Ben, which is super tactical. That is, what are you writing in the agents.md file as of February 23rd? We have to put this disclaimer. Tomorrow might be a completely different file.
It changes every week, right? You try new things and you realize it's getting too big, and then you change. And yeah, we have ours. It's available on GitHub, right? But depends on what you want to do, right? So for me specifically, I'm doing refactoring only with my agents. I mean, they are very, very dedicated refactoring instructions. So it's about thinking in planning a bit in steps, and then measuring code health frequently, making sure you react on the output I get from the MCP server, and then rerunning tests after having done small changes, right? So I try to incentivize short iterations, small changes, right? We've heard about this also in recent time. Adam, what's yours?
Yeah, I have like 3 things in mind. So, by the way, it's open source. If you go to GitHub and the CodeScene MCP, you can check it out. So the first thing I have is rules for safeguarding, where I specify that the code health of 10.0, that's optimal. That's what you should aim for. Never, ever allow a regression. The second one is refactoring. So if you come across code that is not yet AI friendly, you need to uplift it. So I have a mini process for that. And the third thing I have is, and I don't think many people do that. We are not good enough at advertising that, but we actually have a connection to CodeScene, the server in our MCP server. So that's where I specify a few points to the AI, so it knows when to go to CodeScene and drag down, collect information about things like the hotspots, technical debt goals, code quality goals. And that's also something I found is quite interesting context for an agent, because it can help you limit risk in a hotspot. You want to take smaller and smaller steps.
Yeah, love this. And allow me a question from myself, because while you were presenting the way the MCP server interacts with Cloud Code, I couldn't help but thinking that a lot of these quality checks, let's call them like that, historically were, one, done by humans, right? But second, most importantly, happening in the CI/CD, right? Instead, we are moving them to code generation, to the code generation step, which feels healthy to me. It's like in the spirit of shifting quality left. But when these things happen, how do you think about code reviews? That is, what becomes the split between what's checked by AI versus what deserves to be checked by humans, for example, in a code review step?
So I think that's it's very interesting, because when done right through the use of, say, the code health codes in MCP, good agentic rules, strong unit tests, then when you get to the review, you don't really have to focus on code quality, because there's no reason at all to see code that isn't 10.0. The agent will take care of that. So that means that the code review can focus on its real purpose, which is to ensure, have we implemented the right thing for the business? Yeah. So I think we can get much more out of this. And then, of course, we're still in the place where we might also want to focus on like architectural principles that have proven really hard to automate with AI.
Yeah, and knowledge sharing, right?
That's a big win. Yeah,
and knowledge sharing, right? I mean, you can actually focus on getting this consensus of how things work. So that's really good for code reviews. And that will be more needed also when you go more agentic. You need to sit down and think and discuss what the code actually does way more frequently and deeply.
Yeah, great answers, guys. So I think we can also move forward with the third part of the presentation with Stuart, and then pick up more questions at the end. What do you think?
Sounds good.
Sounds good. Hi, thanks. So we're going to shift gears a little bit, I guess, because this is sort of loveholidays experience of using CodeScene in practice. I guess not so many people in this call are necessarily going to know who we are. So loveholidays are an online travel agency. We're the third largest one in the UK, and we're growing through Europe. So we're pretty big. We send millions of people on holiday, and we do that using technology. So we're processing trillions of package offers every day, sending those out to people to buy on our site. And technology is absolutely fundamental to our company staying competitive in the marketplace. So it's always top of our minds. And what's recently been quite a big deal for us is, what do we do with AI now that's hit the scene? Because we don't get to compromise on our technology, but we need to move at the same pace as everyone else in the marketplace. Otherwise, they're going to eat our lunch, right? So loveholidays are bedrock that we've built the business on over the last 10 years, has been founded on sort of the DORA methodologies. So we're very big on our DevOps practices. We're interested in code quality and very passionate about shipping good engineering. And just so we're not going to go into the DORA metrics in great depth, but this is sort of a feel of what's going on. So every engineer is deploying many times a day to production, and that's our reality. So obviously we don't want to be doing that with AIs ruining our lunch and starting to damage our code base. So that's something that we're very interested in stopping. We are rolling AI out and we're becoming an AI first organization. And this is the reality for us. So 88% of coders at loveholidays are using code assistants. And when we say code assistants, think agentic code. We're largely using Claude Code. There are other flavors dotted around, but it's pretty much everyone using that at this current point in time. And that bar that you see there isn't just traditional software engineers. This is anyone at loveholidays who is cutting code. So think product, think VPs, think everybody. Our engineers in the traditional sense is around 80 people. So we've already passed that bar and we're moving on. And certainly around my team, many of us have not actually typed code for quite a long time now. So we're sort of around where Adam is, I would say, in terms of how we're moving around. And we're shipping real code. So this is the fraction of code which is going to our production code base and becoming live on our website, where an agent has been involved in the process. And it's accelerating, it's moving on, and we're heading towards that 100% mark. It's not a religious goal, but we're interested to see how far we can push it. And at the minute, we don't see any reason to stop. And one of the gates for us would be quality of what's going through the door and the fact that it was causing damage to the site. But what we're seeing is that this isn't the case. So this chart here is loveholidays change failure rate for our release. So bearing in mind, we're shipping 80 changes per developer per month to production. And that red line at the top is what DORA would consider an elite level of change failure. So we're nowhere near that. And it's very hard to see where AI adoption starts in this chart. For reference, it's around sort of, we're picking up very highly around the sort of 8, 9, 10 point. But we're staying flat, and that's important to us. And we think that's because of sort of the engineering practices that we have in place. And one of the big pieces of work that we had last year was the journey of improving our code health. And the reason that we started on this journey way before AI was because, like the book Your Code is a Crime Scene, we were struggling to maintain high code quality where our engineers were busiest. So if you look at this chart, it kind of tells its own story. We put CodeScene in around January 2025 before we started AI adoption. Like, we couldn't see the future, but we knew that we needed to have a good, strong code base just for our humans. And we started on the journey of focusing all of the engineers at loveholidays on the hotspot code health. And the bet that we placed in January was that if we could consistently improve the hotspot code quality, good things would happen and the code base would follow behind that. And we found before AI hit the scene and agentic coding that this was exactly the journey we were on. If you look at that yellow line, which is our percentage of agentic coding use, you will see that initially, as engineers learn how to use the tool, we did see a dip in code quality. So it does drop, but it picks up really fast. And the fascinating thing for us is that code quality has now exceeded what the humans were doing. And we're moving to a higher level of code quality in our code hotspot. And it's not just the hot code that has moved, it's dragging the code base with it. So our code quality before was good, actually, compared to the industry. We were up there in the top 5%, but it's continuing to rise. And I would say that's a strong correlation with the fact that the production stability is still there. So we're building on strong code as we move. what was even more interesting for Love Holidays was, and sort of stepping back a little bit, was although we could see that our code quality was in a good place, we were struggling to get to the point that our human engineers agreed with us that our code quality was high. So we also placed a side bet that the engineers would agree that the code was improving. And what you can see here is the results of a survey which we conduct every 3 months with our engineers. So we ask them a bunch of sentiment analysis questions. And one of the questions we ask is how they feel about their code base. And so that 0 to 2 scale there is a red, amber, green scale, where 2 is there is absolutely nothing wrong, which is unlikely for an engineer, and 0 is I'm going to find somewhere else to work. And this is the first year in Love Holidays history where the code health has consistently improved from the qualitative point of view of our human engineers. So we've got a lead measure that says that our code quality is improving, and our humans agree that we're actually on a right path, which is kind of cool. But tying it back to how to use AI, now that we've been on this journey for a while, we can segregate against what Marcus and Adam were talking about in terms of AI readiness. So for us, we're starting to think that AI readiness means that you have an average code and a hotspot code where the health is around the 9.7 mark, which I think is in line with what Adam was saying, trying for 10. But this is sort of the band where we say, okay, you're going to have a very good likelihood of success. And then we have a population in the light blue where they've got to the 9, which was the traditional you're doing well. And then we've got the yellow group, which are on their own journey and they're following behind. So when we contrast how the AI ready guys are doing against the healthy guys, and we look to see how they got there, if we take the people who are AI ready now, so these are the people who in February have sort of achieved this holy grail of excellent code. What we see over their journey to get to that point was they were consistently using AI more than the other teams. So they'd adopted it quicker and they were using it. And if you look at the bar at the bottom in that sort of the tiny micro chart, whereas in the previous slide where I showed you Love Holidays as a whole, we had this sort of traditional sort of steady ramp up. What we see with these teams is they ratchet straight up to AI high quality code, where they're in the 9.7 to 10 band. And this is averaged across all of the teams, so about a third of the teams at Love Holidays. And then they anchor there. And that's quite interesting. And what's interesting there is that when we talk to those teams, they're pretty much all using CodeScene tooling as feedback inside their developer loop. So inside their agentic loop, they have done something to instruct the agent to systematically look at code quality, like Adam was showing us earlier. And that allows them to keep into a good place and keep their code quality high. And it's difficult to sort of put a productivity result on this. But if you think about sort of the shift left cycle, the consequence of not having agents in your loop looking after the code quality is that your build is likely to fail when it hits CI/CD, because we've got these gates in the machinery of the CI/CD pipeline. So the engineers are going to find that the CI/CD pipeline blocks them and then throws the code back, and they have to go around their loop again. And this is what we're looking at here on this chart. This is the percentage of build success from agentic versus human commits. So the very dark blue is commits where Claude has been involved, and the light blue commits are the other commits that the humans are making along the journey. We can see the humans are quite consistent. They're generally good at their jobs because we hire people who are passionate about writing good code, and they're doing a good job there. But what we do see is as the adopters of AI have started using Claude around September, you see this massive drop. And this is code bouncing off CD as they're making mistakes. And then we see the tooling improving as the guardrails come in. We get better at using the tool. And now we've got to the point, which is fascinating in September, that the agents are actually better at getting through the CI/CD gates than the humans are in these commits in these teams. So sort of pulling that back to what does our case study tell us from Love Holidays, we would suggest that there's still lots of value in getting your engineering right. So good things come to those who pay attention to their code base and are thinking about their architecture and getting those feedback cycles in. But to what you said earlier, Luca, shifting it left is where the real interest is, because otherwise we're just going to create a CI/CD bottleneck, because you're just going to bash your agents against the tooling, and we don't want this waste in our system. So the better we get at that, the more likely we are to see deployment productivity. So loveholidays deployments year on year are up around 20% from this time last year. So we are going faster. We're not twice as fast, but we are markedly faster. And that's where measuring and iteration comes in, right? Once you've got your system, measure it and be clear what it is that you're looking for. And expect bottlenecks where you didn't think they were before, because as the agents go faster, your process is going to need to adapt. So be prepared for that and think about it. So yeah, I'll hand back to you, Luca, at this point.
Stuart, this was such a fantastic case study. There are very few stories that are this practical and that show the numbers like in this very clear before and after state. I have a lot of questions myself. I will just make one and then maybe pull also something from the chat. And I will be even a little bit provocative, looking at the incredible journey even of your code health, not just AI adoption, right? How it improved from 7.5 to 9.5. Do you think you would have done the same journey if you didn't have even on parallel the AI adoption journey? That if you didn't have like help from AI at even improving the code health, would you have been able to pull this off just for humans, right? Or would you have had the pull, to do that? Maybe you would have had fewer incentives, because as we have seen, AI also benefits from a higher code health. What do you think?
It's a really interesting one. I would say, looking at our data, I can say that the humans were doing it anyway. So because we cared, and it became part of our culture that we wanted good quality code all the time. That definitely happened. I think the appetite is different. Yeah. Because human has to get up in the morning and say, right, I'm going to pick a fight with this terrible piece of code, and I know that I'm working on it, and the excuses are always there, right? Like, we all have reasons why this code was bad, and it's usually like you start by looking in the mirror. But it's easier to say, look, I'm going for lunch. Like Claude, sort it. I'll see you in 10 minutes. I'm going to get a coffee. I'm going to recharge. So I think the main difference is going from, say, 9 to 10, because I think humans, like, we were certainly happy around the 9 mark, but we're perfectly fine with saying, Claude, get it to 10. Off you go.
Yeah. Great answer.
So yeah.
Yeah. So there has been a heated debate in the comments. So rather than like picking the specific question again, I'm trying to pick a topic that people are debating right now. That is how this whole process is changing expectations and possibly the job market for junior developers, and how do you think this is going to impact how they're growing in the industry? What's the need for junior developers on your team? You can even either make predictions or talk about your own experience with junior folks on your team. And of course, this is, I think, a question not just for Stuart, but for everyone here.
Yeah, I mean, that's really close to my heart, because my son's just starting his career as a software engineer and is on that journey himself.
Yeah.
We still need junior engineers. There was a brilliant post on LinkedIn where someone wrote along the lines of, the person who hired you didn't hire you because you knew everything. They hired you because you would learn over time, right? We have to invest. It's an investment in the future of your organization. People are going to age out, do something else, win the lottery. So if we don't hire junior engineers, where are the senior engineers going to be 10 years from now? We will still need them. What they're going to be doing, I can't imagine. It's going to be different. but we still, to what Adam was saying earlier, I think, is like, you still have to have an engineering mind. You have to be thinking about what it is you want and what it is you build. And typing correct syntax for Golang or Python is a very small part of what we do in our day. There's still lots of that left.
Yeah. What do you think, Adam or Marcus?
Well, I have to say that I'm not sure if I should say this publicly, but this is the first time I'm happy to be as old as I am. Because I really think that for me personally, I've benefited a lot from, I've been coding for almost 40 years now. And I'm not saying you need 4 decades to use AI, but without all that stuff I learned about software development, about coding, about design and architecture, I think I would struggle much, much more.
Yeah.
So AI, I think, ironically, we talk about how it democratized software before. And I think that's true for like one-off tasks, one-off prototype. But to sustainably building and maintaining a large code base, I think requires even more engineering skills, even more discipline than it used to do. And that said, I absolutely agree with Stuart that the next generation of developers, they have to, get a chance. They have to get a chance to grow into this. It will definitely be a very, very different journey than the one I took almost 40 years ago. But it's absolutely essential. I'm pretty convinced.
Yeah.
Yeah, so I work as an adjunct lecturer at the university. That's 20% of my time. So I follow the debate with my colleagues, of course, quite a lot. They are more focused on teaching duties than I am, but we are being disrupted at the university level, right? I mean,
Yeah.
And the students are also early adopters of whatever kind of support they can get when it comes to actually programming. And we have been trying to share with our students for decades that it's so much more in software engineering than coding, right? But this is really what we need to continue, pushing, and we need to teach them computational thinking and good design architecture. There's so much more for us to do, but we need to rethink the university system quite a bit also. And then, of course, companies have to take the responsibility and actually recruit junior people, because that's needed for the sustainability of the entire business, right? In the US, this has been a big problem last year, actually. Many very hesitant companies when it comes to recruiting juniors, waiting for where the future is going, right?
Yeah.
But, there's still a lot of job work for us.
Yeah. Personally, I'm not super concerned in the meaning that I think we will figure it out. But I also think that it will need a lot of rethinking, because if we try simply, to map what we know about what makes for a junior engineer today to what people can do with AI, of course, there is not a great fit, right? Because things need to change. But I think it's kind of true even for senior engineers, right? They're operating more and more like managers, right? It's changing their lives as well. So I think we will figure it out for junior engineers, and young folks are brilliant. They adapt very fast, and we'll probably learn from them more than they learn from us, and we will see the best of them, what they do, and we'll point our fingers and say, yeah, that's what a junior engineer now can do. And so I'm not overly concerned by that, but of course then I think there will need to be a lot of adjusting. So maybe we have time for a last question, and I wanted to ask Stuart, since you've said you've been a DORA practitioner and your team for many years, was there a point when you added AI to the mix seriously at the beginning, where you did see your DORA metrics get slightly worse in something before they got better, like in meantime stability or like success rates? There've been research, right, about the fact that activity on the branches improves, but maybe your stability and the error rate gets worse at first if you don't put good guardrails. Did you see any of this yourself?
From the DORA metrics, we were remarkably stable. I say the one noticeable one is this dip in the hotspot quality. And my guess as to why that happened is that the engineers were cautious. So we had a lot of observability and monitoring in place. So our reaction time is very good to changes. We've got good discipline around sort of human review. So it's hard to say why, but my guess would be that this was human diligence in the food chain. If you look at the ramp up, it starts slowly. So I think we were making most of our mistakes with smaller amounts of code and learning and growing in confidence and taking one step. But I think, again, sort of coming back to the points made earlier, that you need to have your unit tests in place, you need to have your system tests, but also, when you're going to let an AI send code out to the wild world, have you got the observability there to see if it's working? And we're very, very disciplined around that. So I think what we see there is that mistakes were rolled back very quickly and detected. I wouldn't recommend doing this if you haven't got that in place.
Love this. Thank you, Stuart. And then I'm mindful about time, so maybe we can wrap this up. Romanella, what do you think?
Yes, I just want to say that we are sending out the recording. We're also sending out the white paper and the research, and also the links to the MCP server, so you can check it out. So yes, thank you so much for attending the webinar, everyone.
Thank you, everyone.
Yes.
Thank you, everyone.
Thanks.
Thank you.